Good morning and welcome to another day of learning, boys and girls. So we're still going to focus on our angles that we talked about yesterday, focusing on the acute, right, obtuse, and straight angles. But today we're going to dive into something a little bit deeper, and we're going to work with a protractor. Before we talk about a protractor, how to read it, how to understand it, we're first going to talk about what makes up an angle. So yesterday we talked about the acute angles that have to be less than 90 degrees. Right angles are exactly 90 degrees. Obtuse angles are greater than 90 degrees. And then your straight angles, which also look like a line, are 180 degrees. But every type of angle is made up of the same thing. Angles are made up of rays. And those rays meet at a vertex. So it's rays that meet at a vertex. So a ray is a variation of a line. However, it's going to have an endpoint, and then it's only going to go in one direction. So this is what a ray looks like. It's going to go one way. This is where our vertex is going to end up being. So when you draw an angle, your other ray is going to start at that endpoint and then go in another direction, and you ultimately have an angle. So where your rays meet, that is going to be our vertex. This angle happens to be acute because it is smaller than 90 degrees. Again, a lot of times you're going to see angles that have kind of that half circle, that semicircle in the middle of them. They don't have to have them. They don't have to be there. The angles that we look at today are not going to have that. They're just going to be two rays meeting at a vertex on a protractor. So for those of us that don't know what a protractor is, have never seen one, have never used with one, this is what a protractor looks like. It's going to be a tool that helps you measure angles. The angles that we look at today, boys and girls, are all going to be relatively friendly to us. However, you can see that your protractor goes from 0 degrees to 180 degrees, and it also goes back the other way from 0 to 180. The reason that it has 0 to 180 degrees on both sides going the opposite direction is because it's going to depend on which way the angle is shown to you. Where this line meets up is where your 90 degrees is going to be, where that right angle would be. On a protractor, when you're able to manipulate with it and use it to actually measure your angles, this is where you want your vertex to be. That's where you want to line up that point so you can get a really, really good measurement as to what your angle is going to end up being. So let's go back to the angle that we just looked at. The angle we just looked at was an acute angle. We're going to draw it out to this 0 degrees, make sure it lines up with that. And then it went up right here, whatever, just a little. So now, when we look at this angle, we need to ask ourselves, first of all, is it acute, right, obtuse, or straight? Seeing that it does not go straight up and across, it doesn't have the square in the middle, it doesn't have anything like that, it does not equal 90 degrees, we can say it's not going to be right. Also, since it does not go straight across from 0 to 180, it is not going to be a straight angle. So now we have it down between acute and obtuse. Thinking back to what we did yesterday, the acute angles are less than 90 degrees. Obtuse angles are going to be those bigger angles that are bigger than 90 degrees. So looking at this angle we have here, it looks smaller, so we can say it's going to be acute. It's not going to be obtuse because it's not a huge angle. It is on the smaller side, so we're going to say it's acute. Now comes the trickier part. Once you have it labeled as acute, obtuse, right, or straight, you then have to look at the degrees that it goes to. So as we talked about, it's going to go from 0 to 180 on one side. Your protractor is then going to go 0 to 180 degrees on the other side. This angle goes between 110 degrees, and 70 degrees. Now this angle and any other angle that you come in contact with is not going to have two different angle measurements. That cannot happen. Angles are going to have one measurement. So thinking about it being acute and thinking about what we know about acute angles, that it has to be less than 90 degrees, we can say that this angle cannot be 110 degrees because that's greater than 90 degrees. So doing a process of elimination, we can say that this acute angle is 70 degrees. A very quick and easy way to check that is to ask yourselves, is 70 degrees less than 90 degrees? It is, so we can say that this is the correct angle measurement for this acute angle. On your worksheet for today, boys and girls, you do have a few practice measurements, a few practice protractors, just to show you that, again, the angles can go this way. Again, it's the two rays meeting at that vertex. However, angles can also be flipped. And that is why it is so important to realize and just to make sure and remember that your protractor goes 0 to 180 both ways, because it is going to depend on where the angle starts. So let's start looking at this angle, because this looks like the one that we just did. It's going to start going this way. Our rays are going to meet at that vertex, and then it goes up to here. So as it says here, we can say angle 1 is an acute angle because, again, it's less than 90 degrees. That's going to be a smaller angle. The ray that's going up lands on the 30 degree and the 150 degree mark. So just like what we talked about in the example before, since it's acute, the measure has to be 30 because 30 is less than 90 degrees. If it had happened to be an obtuse angle that we'll look at in just a minute, the other measurement would make a little bit more sense. Looking at our second angle example, when the angle's flipped, this is a different way of looking at those angles, but again, you're still going to measure it the same way. Thinking about what type of angle it is first, it's going to be obtuse because it's on the bigger side of angles. It's not a small, tiny angle like we've looked at before. It's going to be one of the bigger ones. So this angle measurement has to be more than 90 degrees. The ray going up lands on the 50 and the 130 mark. Angle 2 is obtuse, which means it's greater than 90, so it has to be 130 degrees. So that's going to be the way that we break apart your examples below. You have 1 through 4 on the front, and then you do have more practice on the back. So don't forget to do the front and the back. On the back, it goes 1 through 8. Either way on all these, boys and girls, you are focusing on the type of angle and then what that measurement is. If you need to break it apart, as you did on top, as we looked at on top, and as we looked at the example previously, you're welcome to do that. What I mean by that, boys and girls, is first of all, again, recognize what type of angle it is. This one happens to be obtuse. It's on the bigger side. And the measurement that it's going to land between, we're going to go from this way to our vertex, go up to the other ray. It is going to land between 110 degrees as well as 70 degrees. So this angle lands where our previous one did with our example. However, our example wasn't acute. So we were able to say it's less than 90 degrees. So that's what made it be 70 degrees. This one, however, since we've labeled it as obtuse, because again, it's on the bigger side, obtuse angles have to be greater than 90 degrees. That would tell us that it's not going to be 70, but it would ultimately be 110 degrees. So if it helps you to write out the two measurements that it lands at, the two marks that it lands at, and then go back and think about, well, what is the type of angle? Tell me to get your final answer. You are more than welcome to do that, boys and girls. After you are finished with these problems, please do not forget to go on to Classroom, fill out your forms with your answers. I appreciate that so much. Enjoy your work.